Okay, so if you've ever had to manage a traditional database, you know the pain, right? The headaches with scaling, the costs, they just spiral. But what if you could just completely blow up that old model and rethink how a database should work in the cloud? Well, that's pretty much exactly what Neon has done. They've fundamentally re-architected PostgreSQL for this new serverless world.
All right, so here's the game plan for this explainer. First, we're going to look at the old database dilemma, what was broken. Then, we'll dive into Neon's radical new architecture. After that, we'll get to the fun stuff, the developer superpowers this thing unlocks. We'll also check out the competition and wrap up by figuring out who Neon is actually built for. Let's get into it.
Okay, first up, the old database dilemma. And this really gets to the core of why a company like Neon even exists in the first place.
Yeah, it really all boils down to this one big question. Why are databases so expensive and just so difficult to scale? I mean, for decades it's been this painful, manual, and super expensive process. But why?
Well, the answer is all in the architecture. See, the old way of doing things is what we call monolithic. Think of it like this. Your compute, that's the brains of the operation, and your storage, the memory, they're basically glued together in the same box. So if you need more brain power, you're forced to buy more memory even if you don't need it. And it works the other way too. They're totally coupled.
And this old model, it creates so much real-world pain for developers. You're constantly forced to over-provision, right? You're paying for this massive server capacity just to handle your peak traffic. But most of the time, it's just sitting there, burning money. And when you actually do need to scale up, it's this slow, manual, painful process. It's just a huge waste of resources. And the worst part? It's a single point of failure. If that one box goes down, you're in big trouble. Okay, and that right there is what brings us to Neon's solution, a truly radical new architecture. Their big idea is, it's kind of brilliantly simple when you think about it. What if you could just break that box apart?
And this is the absolute core principle of Neon. It's called the separation of compute and storage. So in this new world, the compute nodes, the things doing all the heavy lifting and processing, are completely stateless. They don't actually hold on to the data. Instead, all your data lives in a totally separate, super durable storage layer. And the magic is, these two things can now operate and scale completely independently of each other.
So how does this actually work under the hood? Let's trace a piece of data. First, your write request hits one of those stateless compute nodes. Then, something called the write-ahead log, or WAL for short, gets sent off to a component called the safekeepers. Their whole job is to make sure that write is durable and safe. And then finally, the data itself gets organized and put away in the page server, which is Neon's own custom-built storage engine.
So here's the bottom line, the really crucial part. By pulling these two layers apart, Neon achieves two incredible things. One, you can scale your compute power and your storage totally independently. And two, this is what enables a true serverless model, where your resources can scale all the way down to zero when they're not being used.
All right, so we've got the architecture down. Now let's talk about what this actually means for you, the developer. This is where we get to the really fun part, unlocking developer superpowers. This is what that radical new architecture actually lets you do. And the first superpower is, wow, it's arguably the most revolutionary one. It's called database branching. And this quote on the screen just nails it. The best way to think about it is like Git, but for your entire database. It lets you create instant, totally isolated copies of your data in a snap.
And here's where that power becomes incredibly real in your day-to-day workflow. Imagine this. A developer on your team creates a pull request. Instantly, Neon spins up a brand new database branch, a perfect zero-cost copy of your production database. Your tests can run against it in complete isolation without messing with anything else. Then, once the PR is merged, poof, the branch is automatically deleted. I mean, this is an absolute game changer for dev speed and safety. All right, superpower number 2 is all about your wallet. It's about cost. Because of that separation of compute and storage, when your project isn't being used, say it's been idle for 5 minutes, the compute part just shuts down. And the cost for that compute while it's off? A big, fat zero. You literally only pay for what you use, down to the second. Now, of course, there's always a trade-off, right? The price you pay for scaling all the way to zero is something called a cold start. So when the very first request comes in after it's been idle, that compute has to spin back up from sleep. That little wake-up process introduces a tiny bit of latency, usually less than 500 milliseconds, so less than a half a second. Oh, and the superpowers don't stop there. There's instant restore.
which lets you recover a huge multi-terabyte database in literally less than a second. You just create a new branch from a past point in time. Then there's time travel, which is exactly what it sounds like. You can query your data as it existed in the past. And on top of all that, there's a super robust API and command line tool, so you can control all of this programmatically, which is absolutely crucial for building things like multi-tenant SaaS apps.
So, okay, Neon is obviously really powerful, but it doesn't exist in a vacuum, right? The market is crowded. So let's talk about the catch and the competition and figure out where Neon actually fits in this whole ecosystem.
One of the big ones you'll hear about is AWS Aurora Serverless v2. And, they share a similar philosophy about separating compute and storage. But there are two massive differences. First, Neon can scale to 0. Aurora can't. That's a huge cost advantage for a lot of people. And second, Neon is open source. That means you're not locked into a single vendor, whereas Aurora is completely proprietary to AWS.
Okay, now what about Superbase? People ask this a lot, and it's a really important distinction to make. Neon is laser-focused on one thing, being the absolute best serverless Postgres database on the planet. That's it. Superbase is much broader. It's a full backend as a service. It includes a database, but also auth, file storage, the whole shebang. Even how they handle branching is totally different. Neon gives you that instant, copy-on-write clone of all your data, whereas Superbase just spins up a new, empty database for you.
So all of this brings us to the final and maybe most important question. Who is Neon actually built for? Let's really pinpoint the exact use cases where this tech doesn't just work, but where it truly shines.
When you look at all its features, Neon is just a perfect fit for a few key areas. First, any serverless app or anything with spiky variable traffic. The auto-scaling and scale-to-zero features will save you a ton of money. Second, development, testing, and CI/CD environments. The branching makes it an absolute no-brainer. Third, multi-tenant SaaS applications, where you might want a database for every single customer. The API makes that possible. And finally, it's quickly becoming a go-to for AI and agentic apps that need to spin up and tear down isolated databases all the time.
And look, this isn't just theory. Neon is already the powerhouse behind platforms that you probably use every single day. Vercel's Postgres offering, that's powered by Neon. Retool, they use it to manage over 300,000 databases for their customers. And Replit relies on it to power their AI agents. It's already out there, battle-tested.
So let's end with this thought. The biggest thing Neon does, its core innovation, is that it makes your database behave just like your code. It can be branched, it can be versioned, it can be automated away. This fundamentally changes the entire relationship developers have with their data. So the only real question left is, if your database can finally act like code, what are you going to build next?